This is image generation, and we are going to use reinforcement learning to improve image generation to make better looking images. I will explain how this works step by step, but just now imagine that from one prompt, a potato, happy potato, we generate multiple images, and then we have a reward for each image, how good it is, if it's good or if it's bad, negative reward if the image is bad. And the problem, during that image generation process, image diffusion process, even if the image is good, some of the steps might be bad. So currently we are rewarding all of the steps positively to reinforce all of the steps as if all of them are good if the image is good. But maybe some of them are bad. And this paper will deal with this issue or figure out a way to deal with this issue so we don't actually reward the bad steps, even if the image is good. Let's first see how to use reinforcement learning to improve image generation. The model is given a prompt, a majestic lion on a rock at sunset. Then the image generator generates multiple images with the same prompt, maybe 4, 8, 16 images. And then there is a reward AI model, that's gonna look at all these images, and reward model is trained to know what humans like. So instead of humans looking at millions and millions of billions of images, reward model will replace them. Reward model knows what humans prefer, it's trained on that. And then the reward model will give a score for how much it thinks the humans will like each of the images. For example, image A can get 15.2 score, image B 13.1, etc. But we will not use these rewards for these images directly in the reinforcement learning. We will not reward this image with this reward. Instead, it's better to look at all of them and to see if one particular image has a lot better reward than every other image. Then that particular image should also be rewarded a lot better in reinforcement learning. But if all of them have similar reward, neither is like a lot better, then that image shouldn't be so much more rewarded than other images. So we want to convert these absolute, unrelated scores to scores that are dependent on other images. So if one image is a lot better than other images, then we will reward it a lot, so the model learns to generate this type of images. And if one image is a lot worse than every other image, then we will punish it a lot, so model stops generating this type of images. I talked about this reinforcement learning process in this video, PPO, LLM reasoning, importance ratio, advantage, reinforcement learning. I'm gonna leave the link below in the description. So the GRPO algorithm by DeepSeek, which stands for Group Relative Policy Optimization, is used to assign rewards to images relative to the other images in the same group, which means other images generated by the same prompt. And this will teach the model how to generate good images. So we have this formula that advantage, it's like how much better or worse it is than the rest of the group. So advantage is images score minus group's average score, all of that divided by group standard deviation of scores. I actually talked about standard deviation in my video as well. Random variable standard deviation variance, if you type that, I'm gonna also leave the link below. But basically what this formula will do is what I just explained. If image is just a bit better than average, it will give it small positive score like 0.23. If it's a lot better than average, then it will get high positive score, 1.23. And same if it's a lot worse than average, big negative score, and a bit worse than average, small negative score. And so we want to keep scores around 1, -1. Neural networks like those numbers around 1, -1, because then when you multiply them, they don't explode. It's not like 1,000 times 1,000 times 1,000, and then you get huge numbers that cannot be represented in memory in GPU. But you multiply 1.1 times 1.2, etc. These small numbers that GPUs and hardware have no issues representing. So I was calling it a reward, but they're just advantage. That's not a reward, the final reward, because final reward will contain something else besides this advantage. And the other part is importance ratio. I explained this in the PPO video that I will leave, that I already left the link below. So diffusion models start from pure noise. And you see each of these steps, they subtract a bit of noise. And every time they subtract a bit of noise, we get a cleaner image. And so each step here is about predicting a bit of noise to subtract. And this is a bit complicated. How does all of this work? There are videos and courses on how diffusion models predict noise, how they work. But the main point here is we look at this final image, and so what advantage it has, so that we explained earlier. So is it a positive number or a negative number? If this final image has a positive advantage, so it's better than average, then we want to make likeliness of each of these noises more likely. So what that means is, imagine that from this step to this step, there are many different possible types of noise that can be subtracted. So if this image is good, has good advantage, then we want to increase the likeliness of this particular noise step that happened, that led to this better than average image of this particular noise step happening. And if advantage here is negative, if this is worse than average image, then for each of these particular noise steps that happened, noise subtractions, noise predictions, we want to make them less likely in the future. So by making them less likely, we will make other predictions, other noise inherently more likely, just because this one we made less likely. But that what I just explained was just about advantage. If the advantage here is positive, then we're gonna make all of them more likely. If advantage is negative, then we're gonna make all of them less likely. But what is importance ratio there? So this is the thing. If this particular noise step, noise prediction, was very confident, very high likeliness, but the advantage was negative, so it was wrong image, then we want to make this particular noise step a lot less likely. So want to punish it a lot because it was very confident, very high likeliness that led to bad image. If it wasn't so confident, led to bad image, is not such a big problem. We don't want to punish it as much. So importance ratio is like judging each step, how confident it was. And this may get a bit complicated. So how do we judge each step? We look at how likely it was before in the previous model, before the last update. So if the last update or multiple last updates made it more likely to happen and it led to wrong, bad image, then we wanna decrease the likeliness a lot more. We wanna fix our mistake. I actually talked about this in that video that I put in the description, PPO. And the importance ratio is gonna ask how much did the likeliness of this particular step increase or decrease from our beginning of the training. And if it increased a lot but gave wrong image, then we want to punish it a lot. We want to decrease it a lot. If it increased a bit but gave wrong image, we don't want to punish it too much. So importance ratio and advantage. And so all of this is the previous method. Now this paper is going to introduce something else here. They will change importance ratio a lot. So the advantage stays the same. We still look at if this image is better than average other images or not, and we assign single reward for all of the steps. But now, instead of calculating importance ratio for every step and then updating based on importance ratio times advantage every step by itself, we will group multiple steps and then calculate single importance ratio for multiple steps, and then update those multiple steps with that. So a single chunk can contain step 1, step 2, and step 3 noise subtractions and predictions and subtractions. And we will calculate the importance ratio here by just doing a geometric mean of all of the steps, importance ratios of every step. So we multiply importance ratio of every step and take a root, so the nth root depending on the number of steps. So here, if we are multiplying 3 steps, we take third root of the product of the result. And this solves the following problem. Imagine the advantage is a positive number, which means every step, denoising step, is rewarded. But what if some denoising steps were actually bad? Maybe this one was good, this one was bad, and this one was good. So this would actually reward and make all three more likely. Now this part was actually quite difficult for me to understand, and maybe I didn't get it even now, but to the best of my understanding, it's gonna target the weight updates. So we want to prevent rewarding of the bad step, or we want to mitigate it. So we will merge like three steps into one, and previously all of those steps had their own update vector. So the way its weights are updated to reinforce the likeliness of that step happening. But imagine that the first step has a good update vector, good arrow pointing in the correct direction, the second step in bad, and the third step in good direction. So by averaging these importance ratios, we will also average these update directions, update vectors. And the two good ones are gonna overpower the one bad update vector for the bad step that we don't want to update in that direction. We don't want the model to increase the probability of that step because it was bad step. So then the model sees just one update direction for the entire chunk, and that will be pointing a lot more towards the correct direction because there was multiple of those correct gradients averaged with just one. For example, just one most of the time, the bad gradient. So the model's parameters will be pushed in a single unified direction for the entire chunk, and this direction most of the time will be strongly in the correct direction because most of the steps should be pointing in the correct direction. So that's gonna be it for this video. Okay, this one was a bit tough to understand. I don't know if I even got it 100%, but... And you can join my school to become AI researcher, and see you next time.